Hello guys, welcome to my channel. In today's problem we're gonna show n to the power of 7 minus n. It is divisible by 42 for any integer number of n. So actually we're gonna show n to the power of 7 minus n congruent to 0 in mod 42. First of all, we can factorize 42 to prime numbers. So 42 will be 2 times 3 times 7. So if we can show this equation, it is divisible by 2 and 3 and 7, we will reach to our solution. First of all, we can factorize this equation as n to the power of 7 minus 1, it is equal to n times n to the power of 6 minus 1. And here we will have n to the power of 3 minus 1 times n to the power of 3 plus 1. And then n to the power of 3 minus 1 will be n minus 1 times n to the power of 2 plus n plus 1, and n to the power of 3 plus 1 will be n plus 1 times n to the power of 2 minus n plus 1. In this part, we have three components of n minus 1 and n plus 1. So we can write them in such a way: n minus 1 times n times n plus 1. These three components, actually they are three consecutive numbers, like for example 1 times 2 times 3, or you can consider something like 7 times 8 times 9. So there are three consecutive numbers. Here definitely we will have a factor of 2, and we will have definitely a multiple of 3. So this part actually it is congruent to 0 in mod 6. So if you can show this component, I mean the main part, it is congruent to 0 in mod 7, we will reach to our solution. Generally, for any integer number of n, in mod 7 we have 7 cases. So first of all, we will have 1 congruent to 0, next one will be 1, next one will be 2, and then 3, and then 4, and then 5, and finally we will have 6. For n congruent to 0, this part will be our solution. So from here we will have n congruent to 0 in mod 7. For this part, n congruent to n, this one will be our solution. So n minus 1 congruent to 0 in mod 7. For n congruent to 2, this part will be our solution. So n2 plus n plus 1 will be 4 plus 2 plus 1, and this one will be equal to 7, and 7 will be 0, congruent to 0 in mod 7. For next one, this part will be our solution. So n2 minus n plus 1 will be 9, minus 3 plus 1 will be 7, and 7 will be congruent to 0 in mod 7. And for next one, which is 4, once again this part will be our solution. So n2 plus n plus 1 will be 16 plus 4 plus 1 will be 21, and 21 will be congruent to 0 in mod 7. Next one, which is 5, once again this one will be our solution. So n2 minus n plus 1 will be 25, minus 5 plus 1 will be 21, and 21 it is 0 in mod 7. And finally 6, and for 6 this part will be our solution. So n plus 1 will be 6 plus 1 equal to 7, and 7 it is 0 in mod 7. So we show for any integer of n, a part of our equation will be congruent to 0 in mod 7. So totally this equation, which is n to the power of 7 minus 1, it will be a multiple of 6 and same time multiply of 7. So totally we can say n to the power of 7 minus n will be congruent to 0 in mod 42. And here is the end of this video. Thank you for watching. See you soon.